My name's Arjun Hassard. This is James. We both work for the Threshold network with a particular focus on Taco. Taco is an end-to-end encryption layer that is end-to-end decentralized. And it's been decentralized from day one. So why is it important to be decentralized from the beginning? What's wrong with progressive decentralization? Well, Taco's early adopters are operating in domains where it doesn't really fly to not have trust reduction from the beginning. The stakes are too high and the data is just too sensitive. It needs to be encrypted under a decentralized crypto system from the beginning. For example, passing on inheritance, cryptoinheritance, to beneficiaries, or recovering seed phrases in general. Another example would be enforcing decryption rights for tokenized media libraries worth billions of dollars, or even sharing of reproductive health data in jurisdictions where a data leak could result in someone being prosecuted. So I want you to imagine there are actually real-world use cases out there that need trust reduction today. They need real, actual, practicable decentralization, and they can't just wait until a project eventually decentralizes. Taco is relevant to any application or project that handles private data, though. In the second half of this talk, we're going to do an interactive walkthrough. If you'd like to follow along, you can head to this link, tacowebdemo.bit.ly, and you can get a sense for how our TypeScript API works. So who the hell are the Threshold network? It's the result of the first ever on-chain merge between NuCypher and Keep. And what emerged was a multi-app network focused on services that are oriented around threshold cryptography. So if you were to take like a sensitive cryptographic operation like signing or randomness generation or condition verification or the provision of decryption material, and you were to assign it to a single server or data custodian or commercial entity, that would obviously be very trustful. What Threshold does is disassemble and distribute those operations across an array of independent machines. There are 4 applications live on the Threshold network today. The most famous is TBTC, which just crossed 100 million in TVL, which is kind of a big deal. And actually is relevant for the other apps on the network too, in terms of like a track record of our honest majority assumptions working. But today we're going to talk about threshold access control, Taco, which is presenting a departure from the Web 2 paradigm with respect to encryption and access control. So we all want versions of the apps we use every day that are non-surveilling, non-exploitative, non-rent-seeking, right? Like a decentralized Twitch, a decentralized Spotify, decentralized ZocDoc, etc. How do we do that? Well, a piece of the stack that's often overlooked is what we might describe as selective decryption. Very simply, how do you make it so certain data is only decryptable by certain devices? So basically, this applies to the vast majority of applications in Web3 and just on the web. The options available to developers today are pretty limited, excluding Taco. You could just go with local, easy asymmetric encryption, or PKI. And this is nice. It is secure. Everything happens in the client. But it doesn't scale beyond a prototype. It's not user-friendly beyond a proof of concept. The next option is even worse. You use Amazon KMS or Azure key management system. You're basically trusting a cloud service. And then the third option is the worst of the bunch. You use a DINO, which means decentralized in name only, i.e. web infrastructure that says it's decentralized, has very swish marketing, but actually if you dig into it, the decryption material, the sensitive keys, are controlled by one commercial entity, or at best a coterie of like a permissioned coterie of insiders. The problem with this kind of decentralization cosplay is that your users' data are at risk of being subject to a rogue developer team, an opaque backroom deal, or just generally a single point of failure, or the more benign outcome where they just never work out how to eventually decentralize. Okay, so how did we launch Taco as decentralized from day one? I'll explain that through a three-step process. So say we want to encrypt some data. We start off by sampling a cohort of nodes from the threshold network, let's say 30. Now, what they're going to do is a DKG initialization. What that involves is generating transcripts, aggregating, and cross-verifying them. If any one of them screws up or does something malicious, then the ritual fails. So it's basically min one honest party. The outcome of the DKG is some public material and some private material. The public material is used to generate a persistent public key. The private material is held onto, or a fragment of that private material is held onto by each of the nodes. Now, from the encryptor or data owner's perspective, they specify some conditions for the data to be decryptable, i.e. for the designated recipient to be able to decrypt it. So let's say my Twitch stream, decentralized Twitch stream, is decryptable if the viewer holds 2 special purpose NFTs. This condition is then embedded along with the payload or the stream and sent out to storage somewhere. Just a quick note on the conditions. They're designed to be very composable so that you can combine them with any kind of like operand. They can be surfaced at different points in the runtime, and at some point we'll be able to update those conditions later. Now, from the recipient point of view, they basically take that payload from storage and present it to the network along with a signature proving they own a wallet that's going to fulfill the conditions I just mentioned, i.e. the 2 NFTs. The cohort of nodes takes this and verifies whether they actually fulfill those conditions. And once a threshold of them agrees that they fulfill the conditions, they provision the decryption material back to the recipient, who is able to assemble it locally in order to decrypt the data. Pretty straightforward so far. Let's jump into 2 case studies of adopters that are already using Taco for their sharing flows. So Masterfile is bringing private NFTs to the world. So whether it's a movie, comic book, track, or a piece of art. Instead of just owning a symbolic receipt that you purchased something at some point, here you would actually own the decryption rights based on the NFT that you hold. So only you can decrypt a given piece of art or asset. It's built on Taco and Arweave, so you have access to that this asset or this NFT in perpetuity until you decide to sell or transfer it. One way to think about this use case, which is quite interesting, is that if we stick with like the Web2 approach, then all of your collections of assets, like let's say, for example, your Spotify collection, you can spend 10 years building it, and then you stop paying the subscription fee, and it's gone. But then if you think about it from the old media company's point of view, they're interested in Web3 and crypto, but they don't want to put these libraries of music, etc., onto OpenSea because they consider that to be persistently, permanently piratable. And so they're interested in the NFT space, and they're actually the ones demanding that the whole stack is decentralized because they don't trust the kind of fake decentralized model. Another high-stakes use case already using Taco. Among other things, Silk is pioneering a form of key recovery that doesn't rely on burdening your mother in being your key recovery contact. So their approach is anti-social key recovery, where you retrieve access to your seed phrase by proving that you are the account owner for an email or another account. The interesting thing actually about their model is that they take the really sensitive payload, i.e. the seed phrase, and they shard it across multiple access control services. So us, Taco, but also Lit. Now that shard that Lit controls, from what we can see, is going to be, at best controlled by like one of these permissioned coteries, like I mentioned before, or like more or less a centralized service. But the shard that Taco controls would be managed by those 30 nodes that I mentioned earlier. OK, so at this point, we're going to hand over to James for a walkthrough of our TypeScript API.
Thank you. OK, so if you did want to follow along, I'll actually just grab that one last time, bit.ly taco web demo. And that'll take you to our GitHub. You'll be able to follow along with this demo. Let's increase this. OK, so this is an extremely simple example of how you'd implement encryption and decryption using Taco Web. First thing, in this situation, we've set up a very simple .env file with some, please don't do this in production, private keys for encryptors and consumers, and some config data about the ritual and the domain. So the ritual refers to the cohort of nodes that Arj was talking about before. The domain is a Taco word for whether we're on mainnet, testnet, cutting edge testnet. That's all we're talking about there. We're going to connect to set up our RPC provider, read in those environment variables, the ritual ID. Here's our RPC provider. And then we have two helper functions, encrypt to bytes and decrypt from bytes. I'll come back to those in a moment. Very simply, we specify the network we'd like to connect to, in this case, Polygon Mumbai. Set up our message string, call encrypt to bytes. We get a ciphertext back, a blob of bytes. We do the exact same in reverse, decrypt from bytes, and we'll get our decrypted message back. So what do those actually look like? Encrypt to bytes. First, you set up your signer wallet. Again, you wouldn't read this in from a .env file. You can do whatever, however suits your use case, coming from a web wallet or hardware, local hardware wallet, whatever suits your use case. We set up our message. We convert it to bytes. Here, line 52 to 60. That's the fun condition stuff. So here we're creating an RPC condition. These can be extremely generic. This one is looking at the balance of the user. So does the user have a greater than 0 balance on chain 80001? So do they have a positive Polygon-matic balance? Super simple. You can do complete custom conditions. So any contract call that is a view that is non-state changing can be used for condition evaluation. So if you have very, very complex condition logic, you can deploy your contract to whichever chain of your choice, specify the address, specify the function signature, the inputs, the expected output, and that's how it's going to be. The nodes are then resolving that call and returning true or false. We get a signer. The user has to prove that they has to provide a signature of the address that's involved that has this positive balance. And then we produce a message kit, which is then converted to bytes. On the decryption side, we're doing extremely simply, just calling threshold message kit.from bytes and then decrypt. This can all be condensed down to about 3 lines of code if you want it to. So let's actually run this. We'll see that it's nice and fast. I think it needs to be much bigger. There we go. OK. Oh, we got a network error. Perfect. Typical. Here we go. So we're getting the signer's address. Our domain is to peer. That's the testnet ritual ID 0. This was the first ever ritual, the DKG ritual that we set up on the network. And then before I've even managed to finish, we've managed to decrypt. So the encrypting message, this is a secret, smiley face. We get our ciphertext back. Really importantly, we can do whatever we like with this ciphertext now. Store it on Arweave, store it on IPFS, send it to someone. It can go anywhere. The only people that will be able to decrypt it are people that satisfy that condition that we sent. The consumer's signer address is this. They then provide a signature, and we manage to decrypt our message again. If we go back, we can have a look at, all right, let's change the conditions and see what happens. I only want you to be able to decrypt this if you are filthy rich on testnet, which I'm not. Encrypt again. We get a different ciphertext because it's using key encapsulation and excellent. Command failed. So we can see here the responses that we get from the cohort of nodes. And it's multiple, unauthorized, decryption conditions not satisfied, decryption conditions not satisfied, decryption conditions not satisfied. So in this case, we can see all of them agree that I don't satisfy the conditions for decrypting this ciphertext, and therefore I'm unable to. All right, pass it back.
The fact that it failed initially with the network error shows that we didn't simulate any of this. OK, so there's just one last slide. Planning to decentralize is not the same as decentralized. I can't emphasize this enough. We've seen in the world of bridges how this can go wrong, multi-chain, RenBTC, but it's also a massive risk for infrastructure. And in some ways, it's worse because if you invest the time and become dependent on components of your stack, you're much more locked into this eventuality that the infrastructure provider doesn't work out how to eventually decentralize. And some of the malfeasance could be happening without you even noticing. A semi-centralized threshold decryption protocol, i.e. using what you might describe as glorified Shamir secret sharing, but then just having it controlled by one entity. That is basically like using a cloud service, but more inefficient. And then the most important point of this talk is that we launched last month. We were decentralized from the very beginning. We're on like day 50 now. We already have over 100 nodes running Taco software, which is amazing. And we also are generating revenue from a diverse set of use cases, which is also ahead of schedule. Our testnet to peer is open for anybody to hack on. And yeah, thank you so much for being here.